I started in 2011. I'm mainly focused on developing the compiler in terms of projects. When we have to solve problems related to anything electrical, that's my specialty. I think that the biggest difference and why I have been using our own tool for many years in my work and also my side projects is because with our tool is very easy to create models, to create custom models. I have used many electrical simulators, and the ones I used in the past had that issue, right? That you had certain fixed components, and if you needed something more abstract, something that is not covered by any component provided in the simulator, you had to adapt it a little bit or do things in order to get to simulate what the special component that you have. But with System Modeler, it is very easy to create your own models, changing the levels of abstraction. For example, you can start creating a very abstract model of whatever you are simulating, and then adding more details. So making it more concrete. To give you an example, let's say that I need a controller for a system. So I can start using blocks to create my controller. But then I want to build it. And if I want to build it using electrical components, then I can change it easily in order to simulate again with the whole system. Some years ago, there was a library to model the human body, the way insulin absorption works in a human body. And those kind of things are very surprising for me because when I see everything from the electrical part, and that looks like completely strange for me and mysterious. I have a hobby that aligns very well with the work that I do with System Modeler, because I like electronic music, and I like the synthesizers, the machines to create electronic music, especially like the old synthesizers, like analog synthesizers. And one of the things that I've been enjoying a lot in recent years is to create simulation models of those. I even have a few blog posts in the Wolfram blog where I describe the process to model, and they creating digital versions of those electric circuits made for music. And what I do as well is I create circuits that behave like that.
Hi, I'm Natalia, an application engineer at Wolfram. I studied aeronautical engineering at Linköping University, and now I work on an aircraft library in System Modeler. My work helps other engineers to optimize their work by using pre-made components from the aircraft library, which makes it easier to build and simulate flight dynamics of their aircrafts. I have also been involved in bringing old projects back to life, creating guidance materials for the System Modeler users. Outside of work, I enjoy spending my time mostly far from the computer. My hobbies include dancing with elements of acrobatics, campings, and all other random activities.
I've been involved in adding support for the functional mockup interface standard that allows models developed with a variety of different tools to be included with simulations built in System Modeler using this open standard called FMI, Functional Mockup Interface. When we build models with Modelica, there are naturally arising sometimes quite large equation systems with sometimes even hundreds of variables to be solved by a nonlinear equation system solver. A key part of what a Modelica tool needs to do is to apply the so-called equation system tiering to bring down the dimension of these sometimes very large equation systems into a small number of manageable variables where there is a chance of actually having guess values for all the variables being solved for. And it is also can have a tremendously good impact on solving performance when you reduce solving something in hundreds of variables to maybe 10 or 20. Would probably say my favorite hobby is tango dancing. So interested in outdoor orienteering competitions when there's always something for parents to do outside of the competing classes.
I work a lot as a consultant using System Modeler to solve problems for customers. So I do a lot of everything from electronics to control design. I'm a PhD in vehicular systems, and the focus there was on modeling and simulation of internal combustion engines with combustion, with heat exchange, with flows, etc. So I started working a little bit with the media fluid libraries, and that was my original specialty when it comes to simulation. I really mostly use System Modeler as a simulation environment for trying out control implementations these days. One thing that System Modeler contributes is this notion of not having to decide, for example, my states in a model. Let's say that I have a combustion engine, I have a transmission, and I can have a transmission that is either stiff, meaning that we have a fixed ratio of input-output, but we can also have a transmission that is flexible. And let's say that I use like Simulink or another competitive tool, then I would have to model I would have to decide in my model, am I going to use the engine speed as the main parameter, or am I going to use the wheel speed? And this, depending on which one I choose, I then have to send this value as a signal to the other models. It's just a modeler. I can just connect my transmission with my engine. When you start using it and you see how it's built up, you start to realize a lot of things about physics that you might not have realized before. For example, my brain works with electronic circuits. I understand things as circuits. So if someone comes to me with a mechanical problem, I know that like torque and speed are almost the same things as current and voltage. So when we connect two things in System Modeler, like 2 points with the same voltage, they have the same voltage, and that's just the laws from the basic foundations of electronics. And the current that is flowing through the circuit has to sum up to zero. And we have the same thing with mechanical circuits, and we have the same thing with a lot of domains. So a lot of that, and this is the connector idea in System Modeler. But I also do a lot of outdoor activities. For example, I'm running orienteering in the forest, and tomorrow actually I'm going to have a indoor orienteering event at the office where I'm going to teach my colleagues how to do indoor orienteering. But it's a little bit harder than arranging a marathon because everyone has to fit inside the building.